Remember to, okay, so I've taken roll and now we're going to be looking into, I'm going to go to speaker view and, okay, I'm going to put the chat over there, I guess. And if I get up that view, so here was this thing here, right? Scan PDF of proof and attach. And so I'm begging your forgiveness, gonna walk through here and look at the results together. All right. I've already scored them. There wasn't a lot of points. It was just like, you know, just so that for the sake of having points and getting used to that idea. So I'm going into the, is this, I think, is this called the speed grader is what I want to look at, right? So, and so this was somebody I think sort of copied this and submitted it or proved this in their own way maybe and submitted it, but that isn't actually what I asked for, right? What I asked for, write a proof to the theorem that the diagonals of a rhombus, oh dear, I misspelled rhombus. That's embarrassing. Rhombus are perpendicular bisectors. Scan it as a PDF and attach that to your response to this prompt. Okay, so I'm going to save that because I just changed the spelling of rhombus. And now if I choose this thing, do you see this? Yeah, so one of the options I have is what they call speed graver, which sounds good, but actually it's only fast. I mean, I guess it's sort of supposed to be efficient, right? But Adrian, I don't think you're here. So you also did not submit one. Brianna, I don't think Brianna was here either. Is that right? Contreras, yeah, those are both not here. And neither one of them submitted this by the deadline. Dylan did submit it. And you can see I have a comment there. If I open this in, yeah, so you can see what he turned in. I'm sorry, Dylan, if is this supposed to be private? Whatever, right? We're all friends. And so a nice diagram and a nice statement of what is to be proved, right? The diagonals of a rhombus are perpendicular bisectors, well stated. And so we have in the left column, the statement, and the right column, the justification, which is just sort of implicit here. That's all right. We know how this works. And so we're given parallelogram ABCD. All right, because we know a rhombus is a parallelogram. So yeah, that's good. And I would like to be able to write on this thing. I mean, this is my practice for 300 some years of teaching, which is, you know, I mark on your paper and then return the paper to you. I don't really know how to do that with this. I can kind of do it, but then I would have to save it and upload it as a response. And that gets to be kind of a lot of work. So I just sort of put my comments in the response box. So you should see that. In any case, it's a fine photograph. There's a bit of a shadow here, but that doesn't really interfere with things. So that's good. And so this next line that says AB is congruent to BC is congruent to CD is congruent to AD. I think that's correct, right? That's the definition of a rhombus. A rhombus is an equilateral parallelogram. I think that's the definition. Works for me anyway. Then we have AE equals EC and BE equals ED. And the definition, the justification there is that the definition of a parallelogram bisect each other. All right, I mean, so these justifications tend to be sort of terse, right? And so that this is terse, and that's fine. But I don't think that's the definition of a parallelogram. It's the definition of bisect together with the proposition or the previously proved theorem, if you like, that the diagonals of a parallelogram bisect each other, right? And so we know that, and we know by the definition of bisect, that means it forms into two equal sections. So, I'm not going to ding you for this, but I would word this a little bit differently. All right, so at this stage, we have that, yeah. So triangle ABE is congruent to triangle BCE. Do we know that? Yeah, we have a common side, BE, right? And we have the other two sides also congruent. One because it's a bisector, the diagonal bisects, and the other is because of the definition of a rhombus, right? So side, 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 that's a good justification. And then we have that angle AEC is 180 degrees. It's a straight angle, definition of straight angle, very good. And we know that angle AEB plus angle BEC is 180 degrees. Well, that's just another way of saying the whole is the sum of the parts. So I don't think this justification is quite right, right? Because you really haven't used this side, 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 right? So you would say that angle BEA equals angle BEC because those are corresponding. So I would say that, but that's not what you're saying here, right? So then you say angle AEB equals 90 degrees. Yeah, so I think that what you want here, and I didn't really catch this the first time I read it, is that angle AEB, this angle here, is equal to angle BEC, right? And those are adjacent supplementary angles that are congruent. And so they must be 90 degrees, which you could, include another step in there. I don't know. I'm not going to try to use the surface. But yeah, so let me just say that looked great. And I can then put this away and we're back to where we were. And I skip on to the next person. And we don't have a submission. So if you want to submit something late, I guess that would be all right. I mean, it's actually kind of important. So maybe I'll extend the deadline for this, right? Because why is this important? It's not so much the actual substance, but that you can do this, right? That you can scan and submit a scan. I mean, that's going to be crucial to our further progress in this course, right? Yes, okay, thanks for the reminder, Kaya. We can do that, but I just want to sort of make the point, so we don't have to read all of these in detail. Xavier also, Blake, Intravia. Did you come in, Blake? Yeah, Blake is here. And again, no submission for this, so that's not great. Kevin Jimenez, I don't think is here today yet. And Ida Leva, we could look at that. But as you can see, a lot of people just didn't submit this yet. So let me say this about that, which is that you got to submit this thing. And so let's see, there's no real easy way to kind of get out of the grade book here. Just have to edit the URL. I mean, there probably is, I just don't know what it is. But so if I go back to here and say, edit this, and then let's take Kaya's suggestion. But first of all, let me say that the due date is going to be changed to tomorrow. How about that? All right, so you can still submit this. Figure out your technology, right? If you want to see me during office hours, we can discuss that as well. Okay, so we want to go to modules, and there was some question about geometry 4, which is here, right? And that was, so Gail Salgado is chiming in. Yeah, I knew that you were here. Oh, and then Kaya said, can we go over homework 4? Okay, yeah. So let's do that. So here's geometry homework 4. And we know that angle DAE is a straight angle. Um, and I guess more importantly, we know that DE is parallel to BC. How do we know that? These little arrows, right? And so Y is equal to 40 degrees because those are alternate interior angles, 40. And X is equal to 60 degrees because that's another pair of alternate interior angles when transversal AB cuts the parallels, it makes these alternate interior angles congruent. When AC cuts the parallels, it makes this other pair of alternate interior angles congruent. So we're good there, right? That one was relatively easy. This one, what do we know? We know that the opposite, this is a parallelogram because the little arrows, opposite sides are congruent. And so 30 is equal to Y. So Y equals 30. Those are alternate interior angles when the transversal, the diagonal cuts the parallels, right? And so since this is 30 and the sum of the interior angles is 180, that means X has got to be 40, right? So yeah, stop me if you have a question. So here, X is opposite A, so the opposite angles, this is a parallelogram again, the arrows. So the opposite angles of a parallelogram are congruent, so A equals C, which is measured as X. So X is the number and C is an angle, and X is the measure of C. And Y is this little angle here, so this is a perpendicular. Okay, so that means that angle CBE is also 90 degrees, right? Because those are same side interior angles when the transversal BE cuts, and they've got to be supplementary, and one of them is 90. So the other one is also 90, right? So that means that Y is 10, right? That means that A is 80. And so A is equal to X, which is also 80, and Y must be 10. Yeah, makes sense? Okay. Hearing no objections. Here, what do we know? You know, this is 120. These are vertical angles. So 2x minus y is 120. I'll tell you what, I think I can draw here, right? Put that off to the side. If I draw on here, yeah, okay. So I want to draw over here, right? So I have that 2x, oh, I can't draw 2x minus y is equal to 120. So that's one equation with two unknowns, right? And in algebra, we learned, I guess I should just say 120, right? Never mind the degrees. As a number, 2x minus y is the number 120. Now, are these parallel lines? They don't really make that clear. I guess maybe the arrow, okay, yeah, the arrow on each one indicates that those are parallels, right? So that means what? That corresponding angles are congruent, which means that x plus y is also 2x minus y. 2x minus y, are we good with that? I don't have access to the assignment anymore. Yeah, I can fix that. I think edit assignment settings. Oh, well, I don't want to. I'm going to stay. Okay, I'll make that available as soon as I'm done with this one. All right. So now what do we have here? We have a system of two equations and two unknowns, right? Let me go back to there. Okay. And how do you solve a system like? Well, you solve one. You know, there's a bunch of ways. We could say if the left sides are equal to the right sides, then the sum of the left sides is equal to the sum of the right sides. And let me try to line that up better because it doesn't look very good as it is, right? So this is x plus y is also equal to that's not going to work, is it? So let me write it up here. Sorry. How about here? Oh, is that? I don't know where are these things supposed to go? Can I see my cursor? Okay, so I'm going to write here that x plus y equals 2x minus y. Those are corresponding angle measures, right? So let's write an equivalent equation for that, right? So what's that equivalent to? This is my equivalent symbol. It's a double arrow. So this implies the left implies the right and the right implies the left. So I'm going to just subtract x from both sides and subtract, well, how about this? I'm going to add y to both sides and subtract x from both sides. And that tells me that x equals what? 2y. Move this over. Yeah. You see how that follows from there? So I'm going to take that and substitute it in there, right? So this is the method of substitution. So you have two equations and two unknowns. You solve one for your for one variable in terms of the other, and then substitute into the second equation. So if x is 2y, then 2x is 4y minus y is 120. And so 3y is 120. And y is then 40, right? Now we know that x is twice y, so x must be 80, right? Yeah, let me scroll to where we're supposed to be here. And so x is 80 and y is 40. Is that what you got for this one? Okay. So let me submit. Yeah, so these are all correct. All right, that's good. Then I'm going to go down here and say edit assignment settings. And I think one of the settings is like when it's due, right? And so let's push that off to tomorrow. Tomorrow and tomorrow. What's the quote? There's a Shakespeare quote. Forever winds its weary path or something. Okay, so I'm gonna select all here and delete that. Okay, and there will be, so you should have access to it now, right? All right, and so let's go to number 2. And we will prove the following. Given that AB is congruent to AC, I don't quite see the whole diagram. Okay, AB is congruent to AC. Does it look like it's congruent? Not really. Looks like it's congruent to DE. Did you wonder about that? Prove that AC is congruent to DF. Yeah, I think that's just a typo there.
Yeah, Professor, that's why I was having issues on some of the homework.
Yeah. All right, let's fix it. And what's the easiest way to fix it? Okay, let's go here. I'm going to go to My Open Math.
So we already submitted the homework and we don't have any attempts left for like certain questions. Are we going to be able to resubmit those or?
Yeah, so I can look at, so this is homework 4, and let's see, I don't mean to pick on particular people, but who would like me to fix their situation?
You can look at mine, Professor. I don't mind.
And so you are, sorry, I can't,
It's Kyle Weaver.
oh, Kyle? Okay.
Because I only attempted 1, 4, and 5 because the rest of them, I was reading them and just didn't understand.
Yeah, and when there's a typo like that last one we just looked at, that's especially
And
troubling.
5, I completely just didn't do. But 1, I had miss attempts on.
Okay, so that's good. Oh, so I'm not in the grade book is the problem. So let's see, how do I show? So are we looking at just the first problem? No, we're looking at, so you got that one right.
You could clear all the scores. I mean, I only have questions 1, 4, 5, and 6.
Oh, okay. That makes it simple. Clear. I think this is just for you, right? Yeah. Really clear. Okay. And if anybody else would like me to do something similar, let me know. Meantime, let's go back to trigonometry, and we'll have to scroll down here to where that is. I believe it's in week, yeah, so it's this one. So do I open it here? No. I go to here and say questions, right? And so this was the second one, right? Didn't take me long to find a typo. So edit code, right? And so given AB is congruent to AC, that was wrong, right? What was it, DE or something? Let me go back, yeah, DE, right? So, sorry, I know it may not be funny if you're like suffered through this. I can't help but laugh at myself and my foibles occasionally. Okay, so I'm going to say save. Okay, so now if I go back here and I say reload this, and I go to question 2, it now says, given that AB is congruent to D, that's better. Thank you. Okay, so proof it is good to make a plan before jumping into a proof. A good plan here is to use ASA to prove triangle ABC is congruent to triangle DEF. And since corresponding parts of congruent triangles are congruent, the desired result follows. We are given a pair of equal sides, AB equal to DE. I suppose that's going to be wrong now because I don't think so. So now in transversal, and how do we want to describe that? There's only one transversal here, right? Which you could describe in a lot of different ways, right? We could say it's AE, right? This is the line that cuts across all the parallel lines. So when it cuts parallels AC parallel to DF, it forms corresponding angles. So which are these alternate interior, corresponding, alternate exterior, also congruent. So BAC, where is that? Okay, there's that. And that's going to correspond to EDF. Those are corresponding. These are corresponding angles. BAC congruent to EDF, right? And ABC congruent to DEF. Thus, by the angle side angle, right? We have angle A congruent to angle B there, and angle B congruent to angle E, and the included sides are congruent. So that's angle, side, angle, right? We know that triangle ABC is congruent to triangle DEF, and it's important to get the characters in the right order there, right? Because A corresponds to D, B corresponds to E, and C corresponds to F, right? All right, and since corresponding parts of congruent triangles are congruent, we have our desired result. All right, let's see how well I did. Okay, so that turned out to work all right. Once I fixed the typo, it's a good problem now. Questions about that? All right. Let's move on to number 3. And boom. Okay, so given AC is congruent to BC, and notice that those are marked with decorations, strokes that show that they're congruent in the diagram. Angle B is congruent to angle E, and again, those are marked with a little decoration indicating congruence. Prove that AB is parallel to DE. Oh, sorry, yeah, AB on the top is parallel to DE on the bottom. So what we want is either get corresponding angles or alternate interior angles, I think are going to do here, right? So is that our plan? Triangle ABC is isosceles, isn't it? The base angles, I mean, yeah, and the base angles on isosceles triangle are congruent. So angle A is going to be congruent to angle B. And by transitivity of equality, angle A is congruent to angle E, which are alternate interior angles. Let's see how this works. We are given, right, pair of equal sides, AC congruent to BC. That's just reading comprehension. Thus, triangle ABC is an isosceles triangle with base angles CBA congruent to CAB, or you could say BAC. Either way, I think is fine. Now, when transversal AE cuts AB and DE, it forms congruent alternate interior angles. So AB is parallel to DE, which is what we wanted. Oh, I misspelled isosceles. My orthography is suffering today. Isosceles. Is that better? It's not very tolerant of misspellings, is it? I think I can actually make it more tolerant of misspellings, but you should spell isosceles correctly. Don't do like I did. All right, and plus it's then fairly easy to fix if you do misspell it. Question 4. Seeing no questions in the chat or anybody chiming. So what do we have here? We have, okay. We have a given quadrilateral with perpendicular bisector of AB, PR, and perpendicular bisector of BC, PQ, and angle bisector RD. Describe PQ and R as equidistant point in the above figure. P is equidistant from, okay, so this is, P is equidistant from B and C, right? Because it's on the perpendicular bisector of BC. All right, that means it's equidistant from B and C. Q is equidistant from B and A, right? It's on the perpendicular bisector of AB. And R is equidistant from CD and AC, right? And we don't actually mark those distances here. Would it be possible? What are those distances? So the distance from R to CD, you want to draw sort of the perpendicular, right? So that would be the distance there. And if I can drop a perpendicular down here. This would be the distance to AD. And so what we have is that this is the same as that, right? That's indicating that they're equidistant. Okay, well, let me submit this and see that it's all good. Oh, AD, idiot. I'm sorry. I shouldn't insult anybody that way, even myself. Okay. Yeah, just to, I mean, I was thinking AD. I don't know why I wrote AE. There is no E. Yeah. So that was a typo. Okay, so find X and Y for each figure. Do we have enough information to? Oh, we know that ABC is equilateral. Okay. So that means that these angles here are both 30 degrees. What here? This is 30. Why? Well, because the angles of an equilateral triangle are all 60 degrees. 60, 60, 60. So when you bisect a 60-degree angle, you get two 30-degree angles, right? So that one there in particular is 30. What else do we know? Well, we know that the exterior angle is the sum of the alternate interior angles. And so angle ACD is 120 degrees. So that means that this is 60 degrees here, right? It's bisecting 120. CE is bisecting 120-degree angle there. Also, it's supplementary to, you know, this interior angle C, which is 60. So get it that way as well. So what do we know? Do we have enough information? Well, we know that this is also X here, right? Since those are vertical angles. And we know that this is 60. Whoops. This is 60. So X plus Y plus 60 is 180. Shall we write that down? X plus Y plus 60 is 180. It's awkward writing this way. Boy, do I miss the whiteboard. 180. Oh, I guess I'm at the edge of my window here. Okay. 180. And what else can we say? Well, we know that this angle here is also 60, right? And what's this angle up here? Well, this is supplementary to X, right? So for triangle, can I label this point F here? Okay, so triangle BFC is a big freaking calamity. In that triangle, we know that the angle at F, one of the angles at F is supplementary to X, right? So that's 180 minus X. Yeah, and then the other two angles add up to 90. So I'm just going to write 90 because I'm sort of short on space here. And that's the sum of the interior angles there, right? So that must be 180. Oh, okay. Well, that tells us a lot, doesn't it? that tells us that x is equal to 90. Which wasn't obvious, right? I mean, it may look like it's 90, but yeah, you can't just deduce by appearance, right? You have to sort of do what I did here, right, to deduce that. All right, so what does that give us for y then? Well, if x is 90, go back to that first equation, and you're going to have 90 plus 60 is 150, and subtracting that from both sides, you're going to have 30, right? So y is 30. X is 90 and y is 30. We know that a is 60 and that half of b is 30 because the other half is 30. A is 60, that's true. And half of b is 30, right? Oh yeah, okay, fair enough, yep. So maybe I took the long way around, right? You're quite right. So somehow or another, yeah, that's good logic. Nice work, Maria. So 90 for X, did we say? And 30 Y. And let's check that, make sure that, oh, I didn't do this. So we have another one here. Okay, let me clear the decks here. So over here, yeah. What's going on here? X plus this angle here, which is, okay, we can write that in, can't we? This angle has got to be what, 50, right? Because the acute angles of a right triangle are supplementary, right? Sorry, that should be a little degree sign there. Okay. So we know X plus 50 plus Y is 180. We know this is equilateral, so this is 60, which means that Y is 30, which means that X is 100. Right? Make up for taking too long with the other one by doing this too quickly. Is that clear though? Y is 30 because it's complementary with C. The acute angles of a right triangle are complementary. And so Y plus 60 must be 90. So Y is 30. That means that X plus 80 must be 180 straight angle. And so X is 100. Okay. And this time it'll accept that answer. And I can go up here and pick the next one, which I need to clear out the flotsam here. Find the measure of each interior angle of the figure described. A triangle, if the angles are in the ratio of 1 to 2. And they want a comma-separated list here to indicate that, right? Okay. So 1 to 2. That means two of them are equal, and the third one is twice that, right? So I think what we can say is, you know, if the angles are, can I write this down here somewhere? Where's my, okay, so X plus X plus 2X must be the sum of the interior angles, right? And that must be 180. So that's 4X is 180. That means that X is 45. Right, that's an isosceles right triangle. Right, so 45. Commas said in non-descending order. That means the numbers don't get smaller, which is fine if we do it that way, right? A quadrilateral, if the angles are ascending in order with each being 16 degrees larger than the next smaller. I'm not sure what the same rule means there. Each ascending, oh, same rule as to how you enter it, right? So in non-descending order, okay. And so, well, I'm going to clear the decks here so I can have some more space. And what can we write here? If the smallest angle is x, then the next smallest angle is x plus 16, right? 16 larger. And the next largest, the largest angle, I guess, is going to be 16 larger than that. And so that's going to be x plus 32. And that's the sum of the interior angles, which must be 180. And so 3x plus 48 is 180, right? Sorry, that's so difficult to write.
I have a question.
Yeah.
It's a quadrilateral. Is there supposed to be a
Oh, quadrilateral. I completely ignored the quadrilateral part of it. Thank you for that. Yeah, got to pay attention to what I'm reading. So this is, yeah, there's one more angle then, right? And that's going to be x plus 48. Can I fit this in here? And now that's the sum of the interior is going to be two triangles, right? And so that's going to be 360. I don't know if does that look like a 360? Oh, it's not even visible there. So maybe I'll write down here equals 360, right? And I guess degrees, whatever, right? So that's going to be 4x plus 96 is 360. Let me write that over here. So this is going to be 4x, right, combining like terms, plus 96 is 360. Taking away 96 from both sides gives us 294. Sorry, that's wrong. 360, I'm writing it down, minus 96. I shouldn't try to do these things in my head because I invariably screw up. So this is 264, right? Okay, I knew that. And so I want 1/4 of 264, which is 44? Oh, sorry, 66. Yeah. Okay, so x is 66, right? Can I write that here? You want to check that that works in the original equation? Well, no. I mean, it's more trouble than it's worth, right? So I'm going to write 66. Does that seem intuitively correct? I suppose it could be, huh? Can we construct such a quadrilateral? Maybe go to GeoGebra, construct such a. Let me show you how to do this in GeoGebra, just for the sake of it, right? And for that, we want to go to here and pick out the geometry guy. And so I'm going to make a segment, right? And then I'm going to use the rotate tool, which I don't think we've used yet, right? So
Professor, one question. Why would you start the equation with x instead of it being x plus 16, then x plus 32, and then 48, and then x plus, what would be the next one, 60 something?
Yeah, but there's only 4, right? So x is the first one, x plus 16 is the second one, x plus 32 is the third one, and then the last one is x plus 48.
Oh, so you wouldn't start with x plus 16?
Oh, I see. That's where you have that question there. You could, but then, you know, the smallest angle would, you'd have to, whatever x you found, you'd probably find x is 50, right? And then you have to say, well, the smallest angle is then x 50 plus 16, which is 66. So that would work. It's just a little bit more complicated than what I did. Yeah. So construct, measure, lines, circles, polygons, transform. This is what I want. Right, so rotate around a point. You see that option? So I want to rotate this thing. Well, actually, let me say those things. Oh, cancel. Okay, so I've got the rotate around a point. Oh, I got a point C for some reason. I'm just going to ignore it, okay? So I'm going to pick these 2 things, or maybe that thing. Cancel. Oh, got another point. How do I erase these points? I suppose I could just move them out of the way, huh? There, go away. Okay, so I want this rotate tool. Rotate around a point. So I'm just going to say rotate this thing around this point. Counterclockwise? Yeah. And how far? Well, 66 degrees, right? Okay. All right. So now I'm going to zoom out a bit, right? Oops. I just want the move tool here. Okay. So now I want to rotate I said 66, right? Okay, so what's 16 more than 66? So I want to rotate this thing around that point. Not 66, but 82, I believe. All right. I don't know, this is looking dubious. Maybe I need to pick another point, or I could, I can't really drag this point, can I? So now I'm sort of insisting that these 2 have the same length, which obviously they don't need to have the same length, right? So let me, can I undo that? Yeah. In fact, let's go back to, we can just undo until we get to here, right? So I'm going to go back to the rotate tool. I'm sorry, this is taking forever, I know. So I'm going to rotate this around that 66 degrees, right? Okay. And then I'm going to pick a different point. I don't want the A prime, maybe. I want some other point here on that line, right? And then I'm going to take this segment here. And then now I have a variable length there. And I can say, yeah, go ahead and I want to hide that. So don't show the object. Okay. I'm going to get rid of me because I'm in the way. And I need to make this a little bit narrower here so it fits in the, okay, so then, yeah, I can just, okay. Okay, so then I also want to hide that, right? I guess I can just hide it like that. I don't want to show the label either. Okay, so that point's gone. All right, so now I want to rotate. Sorry, that was long. Okay, I want to use the rotate tool again. I'm going to say take this and rotate it around that point, 82 degrees. Okay. All right. And so now I can do this, right? I can, let's move things around, right? I can move this to make the whole figure bigger. I can also move this forward or back. And I think I want to move it out, huh? I can only move it so far though, right? Notice that when I contract this, I contract the whole thing. Okay, well, let's see if we can get away with this. So now I'm going to pick another point on here and say, give me this segment from there to there. And then this segment I want to not show. In fact, I don't want to show this either. Oh, oh, I've got this tool, right? I don't want that tool. Okay, it undid that, so I don't want to show that object. And I also don't want to show that object or its label. Okay, so now I want to, so I've got this point which I can move around now, right? I can't move it farther than the segment it was constructed on, but I can rotate. This is a bit of a cliffhanger here, right? Do you see what the hang is? Can we actually construct such a quadrilateral? So I'm going to rotate this around that. And the last rotation was 82 degrees. So now it's going to be 98. That's 16 more than 82. Okay. Oh, okay. So now I want to construct another point on this line segment. And I don't know. It's obtuse, right? I mean, angle D prime here is obtuse. So angle E is also going to be obtuse. And will it connect with A, right? And if so, what will that angle be? All right, so let's finish this quadrilateral by connecting E with A. Now I want to measure where's measurement? Measure. So I want to measure an angle. And I think you want to measure clockwise. Oh no, that's the wrong way. Oh, okay. So depending upon where, so we have the interior angle is actually going to be 360 minus that. And 98 plus 16 is 114. And yeah, that doesn't look good, huh? I can get different angles depending on where that is. But it doesn't look like I'm going to get, and that's just scaling the whole thing, right? Yeah, so this might be a bit of a challenge to actually make such a quadrilateral, right? Oh, okay, so that's kind of getting there if I go out this way, right? And yeah, I can see how this would work then, but I'm going to have to make C prime farther away. So I scale this down. I can't pull C out anymore because the way I constructed this. I could repeat this and get what we want, but it's now 12 o'clock. So let's move back to our matter at hand, which was this one. So did we get, okay, so we got 66. This is an ascending order, right? Okay, so 66, 82, 98, and 114. Is that going to work? Yeah, all right. Number 7 here. And I'm looking at the, yeah, okay, that's what you got. Good. All right. So Find each interior angle of the quadrilateral if its interior angles are represented by these things. Write your answers a comma-separated list in ascending order. And so you're going to have what? You know, the sum of all these things. Let's just add it up on the fly here. So x plus 2x plus 2x is going to be 6x, right? So we're going to have 6x. Is that a 6? Yeah, it's a better 6. 6x. And then what are the numerical parts? -5 plus 20 is 15. Minus 45 is -30. Minus 30 is -60. So I'm going to say that the sum of the interior angles is 360. And that gives us this simple little equation, which says that 6x is equal to 420. Good, buddy. And that means that x is equal to 70. And so are the angles in increasing order here? Yeah, looks like they might be. So if x is 70, then 5 less than 70 is 65. 20 more than 70 is 90. Twice 70 is 140. Take away 45, you got 95, right? So 95, so that's still increasing, that's good. And add another 15, I guess, right? You're gonna have 120. Oh, 110, right? Let's say that that's correct since we're running short on time. If it's wrong, so be it. Then if the measure of the interior angle, so they're in the ratio of this to that, so that means that the ratio of the first, to the second is x to 2x. So I'm going to say, all right, that's x plus 2x. And then the next two are in the ratio of 3 to 2. So they're both going to be, oh, hold on. 1 to 2, but then 2 to 3. Yeah, that's going to be 3. I was right. And 3 to 3 means they're the same, right? And so these have got to add up to 360. And combining like terms, we get 9x equals 360, which means x equals 40, right? And so the sides are going to be, 40, 80, 120, and 120, and 120. And do those add up to 360? I think so. So does that work? Yeah, those are good. Moving on. So today was just kind of, we didn't make any progress today, did we? So we're like going to be even more behind. But, you know, in these peculiar days where nothing is normal, seems like being behind is, well, that's normal. Okay. Yeah, and you know, if you want to get onto the algebra, I'm sorry, we'll get there. Hang on. So I'll tell you what, should we skip on to number? Yeah, we did this one yesterday, right? So these are good. So did you want to look at anything particular on these, or can we make a little bit of progress? Let's try to make a little bit of progress. Okay, so the little bit of progress we can make by going to chapter 6, circles. And yesterday, yeah, I still have yet to finish those. So we'll talk about that tomorrow, but let's see if we can get some progress here. So circle principles, and we had gotten to like principle 11 or something, 12. Oh yeah, this one. This is pretty easy to prove, right? That two congruent chords in a circle are equidistant from the center, and just draw a triangle AOB and triangle COD. You'll see those are congruent triangles because they have all radii are the same. And so by side, 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 those are congruent. So that means that OF is congruent to OE. Principle 13, the same or congruent, or 12, sorry. Don't mean to skip any. Congruent chords are equal, yeah, right, so we just did that one. In the same or congruent, so chords that are equally distant to the center are congruent. Right, so if OE is equal to OF, and this is a right angle, right, because that's the distance by definition, then again, we can say that those are congruent triangles. All right, so they have some solved problems. I would suggest reading those, proving a circle problem. Okay, let's get to the new idea. So tangents, right? So the length of a tangent from a point to a circle is the length of the segment of the tangent from the given point to the point of tangency. What? The length of a tangent from a point to a circle, so that's the length of AP, right? In this diagram, is the length of the segment of the tangent from the given point to the point of tangency. Okay, that's just a definition, huh? Thus, PA is the length of the tangent from P to circle O. Principle 1, a tangent is perpendicular to the radius drawn at the point of contact. This is sort of a biggie you use a lot in your subsequent math courses. So why is that? Well, it's proved in Euclid. I wonder if we can find the Euclidean proof. So radius is perpendicular to a tangent to a circle. Let's see, can I do that here? I'm going to just, well, I don't know what's here, but I'm going to say tangent, circle, radius, perpendicular, Euclid proof, and maybe Joyce as well, right? Joyce being the guy, the Euclid's elements. Okay, so he's just going to book 3, and can we just look for the word perpendicular in here? Definition 4, straight lines in a circle are said to be equally distant. Okay, right. How about the next one? A straight line is said to be the greater distance on which the greater perpendicular falls. Straight line touches the circle and a straight line is joined from the center to the point of contact. The straight line so joined will be perpendicular to the tangent. Right, so that's this one. So we click on that one. So this turns out to be from Euclid's Elements of Geometry, Book 3, Proposition 18. And oh, we're out of time, huh? Okay, so let me remind you that there's the extension on turning in the problem, but let me, from last week, right? So I wonder if I can copy and paste this into a discussion.
So does that mean we're going to be extending homework number 5?
Yeah, we better do that too, huh? Okay, I'll do that as soon as I've done this other thing here, which is, oh, there's that, right? I haven't finished that either.
Professor,
Yes.
should we still expect to have our test on Thursday if
No.
we're behind?
That's what that was the implication of me saying, yeah, we're falling further behind. So it goes. So, and I don't like to have a test on Monday either. So can we count on Tuesday?
Perfect.
I'd gladly test you Tuesday for a hamburger today. And, you know, it's, as part of that, make sure you're able to scan in a PDF and submit it in response to that prompt from last week. So, but if I'm going to say, so the only real progress we made today was a radius of circle perpendicular to tangent. Okay. And that's here, so I'll publish and edit again for some reason, and then paste this in. Okay, look, we get the whole thing along with the picture too. That's nice. Since when can you copy and paste a picture? Which reminds me, Jadzia, I like the way you submitted your PDF. You were able to get it embedded this way.
Yes, thank you. I uploaded it from my phone. I was able to do it through the Canvas app.
Through the Canvas app. Okay, cool. That worked out really great. Perfect. Okay, so let me just remind you of this bit of stuff here when we start out tomorrow, and I will bid you a pleasant afternoon. Any questions about anything before we...
Yeah, Professor, one more thing, sorry.
Yeah, no worries.
So I submitted homework
This is
number
Kaya.
4.
I'm starting to recognize your voices. That's good.
Oh yeah, sorry. This is Maria Sabagal. So I submitted homework
What is
number
it again?
4.
I'm sorry. I thought I recognized your voice, but go ahead.
Yeah. So I already submitted homework number 4, and I didn't get a bad score or anything. I got like 9 out of 10, but I did miss like a couple points from like the ones, I mean, from the problems
that I had wrong.
Correct.
Yeah, I can go through and fix that up for you. So note to self.
Yeah.
Yeah.
I mean,
I think I already made that note yesterday and just haven't done it yet.
Yeah, cool. I like to get as many points as possible.
Sure, I get it. Yeah. All right. So, and I'll extend the deadline for homework 5 and 6, right? That's one thing together. All righty. Well, anybody come in that I didn't count as being here because you were late or whatever? I think I got everybody. So Adrian and Brianna are not here. Yeah. Kevin and Tiana. I thought Tiana was here. No? Huh. I have her is not here. Lola, Andre, I don't see is here today. Kyra Moreno, Carla Rivera. Didn't I hear from Carla? That was Carla.
I'm here.
Carla, yeah, you are. Okay, that's what I thought. Somehow I didn't get you. And Leonardo, not here. Okay. How about Melissa? All right, so I'm going to call that a wrap then. And thanks for your forbearance, folks. We're rough going at times, I know. Take care.